Good day, everybody. And once again, we are back together. All right, so today we are going to be looking at the division of complex numbers. So if you haven't subscribed, please just make sure you are part of the family. Right, for those of you that are joining us for the first time, please just make sure that you hit that subscribe button. Right, so in the previous two videos, I've already introduced complex numbers. And we've talked about the addition of complex numbers. We've also looked at, the introduction of real and as well as imaginary numbers that formulate complex numbers. So today, I want us to quickly look at multiplication. Now we know, firstly, when we've got a complex number, we can express it all the time as z is equal to a plus bi. Right, and we know this is the real part. So this is the real part of the complex number z. Okay, and this would be the imaginary part. Okay, so this would be the imaginary part of z. Okay, right. So we can't really talk about division first before we actually talk about what we refer to as a conjugate. Okay. You'll see just how important a role the conjugate of a complex number is. But first, let's define it. What exactly is a conjugate, right? So, if I've got a complex number, which is z, that's a plus bi, right? So the conjugate is actually, it will always have the same real number, but in this case, for the imaginary part of it, it will have a different sign. So we usually designate that with an asterisk, right? So we say the conjugate of z, so that means the conjugate of z, will therefore be a minus bi. Okay? So let's look at a couple of examples. So if I say to you, write down the conjugates of the following. So if I say, let's write down the conjugate, and you'll see just how important it is, right? The conjugate of the following complex numbers. Complex numeros. Okay? Right, now let's quickly have a look at it. Okay, so let's say I've got a complex number which is z is equal to 3 plus 2i. Okay, right. What would be the conjugate of this guy? Well, we say that the conjugate for this complex number would be, again, 3 minus 2i. Okay, so if I should give you something else, z is equal to 5i minus 6. Okay, it doesn't matter how I choose to write it, whether I start with the real part or the imaginary part. Now, what would be the conjugate of this guy here? Right, remember we changed the sign of the complex number, right? So this would be minus 5i minus 6. Okay, right. Now that we know about conjugates, now we can look at how then can we apply the division of complex numbers. Let's talk about division in just a bit. Right. So suppose that we are given a complex number and it's written in the form. Okay, let's say 4 plus I divided by, let's say 2 minus I. Okay, let me just make something. Right. So let's say we are looking at that and we want to now write it in the form. So if I say to you, write down, look at me saying white, write down, okay, z in the form a plus bi. Okay, so we want to capture the imaginary part as well as the real part. Now, I want you to please note. So whenever we are dividing, I want to get rid of this guy in the denominator. So what do? I will multiply by the conjugate. But now what do? I actually divide, or I multiply and divide by the conjugate. So what would be the conjugate of this guy? So that would be 2 plus I. I did say to you, we always change the sign, but what I do at the bottom, I need to do at the top. So which means I multiply by the same thing. And so this is as good as multiplying by 1, okay? Right, you'd remember that 1 is a multiplicative identity. So meaning anything that you multiply by 1 still remains itself, right? So we haven't changed anything about the sum. All we are just going to do is just change how we are writing it down. So this would be 4 plus I times 2 plus I divided by, look at what we are creating at the bottom, 2 minus I, 2 plus I. If you remember what I said to you, that whenever you've got a bracket that looks exactly the same, but has got different signs inside, then we know we are up for what we call the difference of squares, right? So let's deal with the one at the top first. So remember, we say first, so that's 4 times 2, that's going to give us 8. 4 times I, that's going to give us 4I. That's I multiplied by 2, that's 2I. And I times I, that will be I squared. Right, and this is divided by. Please note, ladies and gents, in this case, when I've got 4 plus A, or let's say A plus B into A minus B, exactly the same thing, just different signs, my answer will always be the difference of squares, A squared minus B squared. So I might as well just take this squared and that squared and just subtract them from each other. So look at this, it's exactly the same thing. So 2 times 2, that will give me 4, right? Minus I times I, that will be I squared. So that in the case will be the product. All right, so let's try and simplify what's at the top there. So I've got 8 plus 4I plus 2I will give me 6I. Okay, I squared. Now remember, we did say I squared. Okay, that's the same as simply saying square root of negative 1 multiplied by square root of negative 1. And what would that give us? That would give us negative 1. So that would be minus 1 over there. Minus, or rather divide by 4 minus, again we've got I squared, that's going to be negative 1. So what do we end up with, ladies and gents? So let's start with the real part at the numerator. 8 minus 1, that gives me 7 plus 6I. And this is divided by 4 minus a negative 1. This will become 5. Now let's write it in the format that we wanted it in. So Z would be 7 over 5. We can write this as a fraction, right? Plus 6 over 5I. So that is the imaginary part. So the real part of Z in this case will be 7 over 5. And the imaginary part of Z, that will be 6 over 5. All right, so I hope that you got that, ladies and gents. All right, now let's go on to find some more examples, right? Okay, so I want us to take the following. So if I should give you an exercise, in fact, I want us to take an exercise together. And you know how the drill goes, right? I'll do perhaps just 1 or 2 for you. And then I will ask you to do the rest for yourself, right? Okay, so let's take the first one. Again, if we've got Z, that's 3 plus 2I divided by 2 minus I. All right, how do we write this as a, in the format? So we want to write this. Okay, so write Z in the form A plus BI. Okay, right. What did we say has to be done? We said we multiply first by the conjugate. Okay, so I'm going to multiply by the conjugate. And what does our conjugate look like? That's 2 plus I. But what I do at the bottom, I do at the top. Okay, so I've multiplied by 1 in essence, right? The multiplicative inverse. Okay, no, actually not the multiplicative inverse, rather the conjugate. Okay, so in this case, let's look at the top. What do we have? We've got 3 plus 2i into 2 plus I. And this will give us 2 minus I into 2 plus I. Right, so we've changed absolutely nothing about it. So 3 times 2, that will give us 6. Again, 3 times I will give us 3i. 2i times 2, that will give us 4i. And 2i times I will give us 2i squared. Okay, right, so I hope that you are getting used to multiplying in using brackets. So in this case, what about the bottom? We said that's the difference of squares. It's going to give us 4. That's 2 times 2. That's 4 minus I squared. Right, so let's try to simplify. So that's 6 plus 7i plus 2. Remember, I squared, we said that's negative 1 divided by, that's 4 minus, again, a negative 1. I squared is negative 1. And so what do we end up with? We've got 6 minus 2, right? So 2 times negative 1 would be negative 2. So that will give me 4, right? Plus 7i divided by 4 minus a negative 1. That still would give us 5. And so what we end up with is 4 over 5 plus 7 over 5i. All right, ladies and gents, that is really how the cookie crumbles, right? So quickly, let's have a look at how would I go for number 2, okay? So let's say z is 4 minus 3i divided by 1 minus 3i. Okay, right. So firstly, what is our conjugate? I can hear you whispering. That's 1 plus 3i. And remember, both at the bottom and at the top, we multiply by the same thing, right? So what do we end up with? So that's 4 multiplied by 1, okay? That's 4. 4 times 3i, that will give us 12i. 3i times 1, negative 3i times 1, that's minus 3i. And negative 3i times 3i, that will be minus 9i squared. Right, what about the denominator? Right, that's our conjugate. That's the difference of squares, or that's multiplication with the conjugate. That's the difference of squares. That's going to be 1 minus 9i squared. And let's try to simplify, ladies and gents. So that's going to be 4. 12 minus 3i will give me 9i. That's minus 9 times negative 1. So remember, I squared is negative 1. And this is divided by 1 minus 9 times negative 1. All right, and finally, ladies and gents, let's go for it. So negative 9 times negative 1, that's going to be positive 9. So 9 plus 4, that gives us 13 plus 9i, that's at the numerator. This is divided by 1 minus 9 times negative 1, that's going to be positive 9. 1 plus 9 gives us 10, so this is divided by 10. And so what we end up with is 13 over 10 plus 9 over 10i. So imaginary part as well as the real part. is 13 over 10. And the imaginary part would be 9 over 10. All right, ladies and gents, just before I give you guys some work, all right, and I just want to remind you of how we would go about adding fractions, right? So if I were to give you, let's say, I give you z, okay, let's say that's 2 plus I divided by 2 minus I plus 3 plus I divided by, okay, let's say 2 minus I. All right, so how do we add these together? Okay, so how can I represent all of this as just one fraction? Well, firstly, we'll go and add our fractions together. What is our lowest common denominator? Well, our LCD, these are exactly the same. So our LCD is exactly the same. And in this case, we just simply keep our numerators exactly the same because our denominator is the same. Otherwise, I'm going to show you just another method if it was a different denominator. So this would be 2 plus I plus 3 plus I. So what do you end up with? I've got 5 plus 2I divided by 2 minus I. All right, I'm sure that you can finish this off. Multiply by the conjugate. This would be 2 plus I over 2 plus I. Give me a comment, all right, of what your answer will be on the comment section, right? On number 3, it would be nice for me to get your final answer over there. Right, and then finally, I want to show you how would I go for it if that fraction did not have, numbers that are exactly the same. So let's say I had 3 plus I divided by 2 plus I plus, let's say, 2 minus 3I divided by 4 minus I. Right, so I want you to note, in this case, we've got our LCD, right? So how do we add those together? Firstly, we'd need to find our LCD. Right, now very important, guys, our LCD would be the product of the two. So that's 2 plus I, 4 minus I, right? But what do we do now? Take the LCD, you divide by the denominator, or in this case, you always can say, well, you just simply multiply that denominator with the first fraction, okay? And you multiply that denominator with the second fraction, okay? Right, so that means you'll have 3 plus I into 4 minus I plus 2 minus 3I into 2 plus I. Okay, so what I normally do is just simply say LCD divided by the denominator and you multiply that by the numerator. Okay, right, so LCD, okay, let me show you what I mean by that. For this, we're going to take the LCD and we're going to say, right, what is our LCD? It's a product of the two. So this is going to be 2 plus I and 4 minus I, right? And then we always say LCD divided by denominator. Now think about it. If I take this LCD and I divide by the denominator, which means that this portion and that portion cancel each other out, and we are left with 4 minus I. And we take 4 minus I and we multiply it by the numerator. So you'll have 3 plus I times 4 minus I. Okay, that's how we got to the one that we had initially. Plus, so there's our plus sign there. We do the same. So LCD divided by denominator. So the 4 minus I and the 4 minus I cancel. We'll be left with 2 plus I. Multiply that by the numerator. So we've got 2 plus I into 2 minus 3I. Right, and there we go. So now we need to try and simplify all of this. So we're going to multiply as quickly as we possibly can. So this is going to be 12. That's 4 at minus 3I. Okay, that's plus 4I. That's minus I squared. All right, so we've dealt with this guy. This is plus. We've got 4 minus 6I. Okay, so that's 2 times 2, that's 4. 2 times negative 3I, that's minus 6I. Plus 2I, that's 2 times I. And this is minus 3I squared. All right, so that's what we have at the numerator. And then what do we have at the denominator? We've got 2 times 4, that's going to be 8. Oops. Okay, let's just fix that. That's going to be 8. Right, that's minus 2I, that's plus 4I, that's minus I squared. Now let's try and simplify this as quickly as we can, ladies and gents. Okay, so we've got 12, we've got 4, we can add those together. Okay, so that gives us 16. But now let's look at the I terms. That's minus 3I plus 4I, that gives us I. Okay, and we've got minus 6I plus 2I, that's minus 4I. Okay, so we cancel those two out. We've already worked out these two as well, right? So that gives us minus 3I, okay? And then we've got minus I squared minus 3I squared, that gives us minus 4I squared. Okay, we're going to still simplify that a bit further. And we've got 8 minus, okay, we've got plus 2I minus I squared. Now let's simplify even further, right? So that's going to be 16 minus 3I minus 4 times negative 1. Okay, and this will be divided by, that's 8 plus 2I, that's minus negative 1. Right, I'm sure by now you all know that I squared will give us negative 1. And so we've got 16 plus 4, which will give us 20 minus 3I. And we've got 8, or rather 9 plus 2I. So this is the simplified expression of that fraction, right? So what do? We multiply by the conjugate in order for us to simplify it. So what is our conjugate in this case? That's going to be 9 minus 2I. But what I do at the bottom, I do at the top. Okay. And so at the denominator, what do we have? We've got 81 minus 4 times I squared. But remember, I squared is negative 1. So in the numerator, we've got 20 times 9. Okay, we've got 180. Okay, that's minus 20 times negative 4, and negative 2I will be negative 40I. And 9 times 3 will give us negative 18I. And this is plus 6I squared. And to simplify this, we've got 180. All right, so we've got 180 minus 40 minus 18, which will give us 58I plus 6 times negative 1 divided by, this is 81 plus 4. Okay, negative times a negative is a positive, so that gives us 85. And so eventually, ladies and gents, we're going to have a 180 minus 6, which should give us 170. That's 174 minus 58I divided by 85. And finally, we've got Z, which is equal to 174 over 85 minus 58 over 85. Please verify if you get the same answer, and we can check together to see that we get exactly the same thing. All right, so we've come to that part where I am going to give you an exercise that you're going to do. All right, please try and give us the answers and let me know how it goes. All right, so let's go for the first one. I want you to work out the first one. So I want you to express the following in the format. So remember, I always want A plus BI. Right, so please express all of them in the format A plus BI. So the first question that I want us to do okay, let's go for this one. Okay, so we've got 1 plus 2i divided by 3 plus I, and you've got right, so this is the most interesting of the bunch. Please try to do these ones as quickly as you possibly can. And you know, I will always give the solutions, but those will be available for members only. And I will see you guys again next time. Please don't forget to subscribe and to like, and I will see you in our next video. From me for now, next time. Sharp, sharp.